Hello friends, welcome back to my channel. My name is Artem, and in today's video we are going to understand the benefits of microservice architecture and in which cases monolith architecture could be better. First things first, let's make a brief overview. What does monolith architecture mean? Monolith architecture is a style where services compose everything in one place and components inside communicate between each other via in-process calls. As you can see here, it's an example of basic three-tiered monolith architecture where we can see a user interface, business logic, and data interface that communicates with a database. Looks straightforward at a glance, and we can't see any issues either, isn't it? But then why microservices came to the world of software development? Microservice architecture is a style where large service split into small services which are loosely coupled, communicate between each other via inter-process calls, and have ability of independent deployment. So let's take a look into real examples where microservice architecture would work better than monolith. Alright, so let's assume we are developing some e-commerce platform. It has monolith architecture, and as you can see, we have a bunch of users that communicate with our monolith via load balancer. Monolith has several services like UI, catalog, discount, orders, and all of them communicate with single instance of database. Let's assume that backend developers going to implement some functionality that required in the future release, and the thing is that we need to redeploy whole application in order to apply these changes. But in case we will use microservice architecture and we will port order service to separate service that will have own process and will communicate with catalog service, we can redeploy only order service instead of whole monolith. So as a result, microservice architecture allows us independent deployment. The second situation, when we expect the large number of users in our platform for a short period of time, for instance, Black Friday, and we are assuming that most of them will use order service. So in monolith approach, we have to extend the whole monolith in order to support these users, but in microservice approach, we're more flexible and we can extend only order service. So as a result, microservices give us additional scalability. The third situation, we can have standard Java monolith application which does job well, and later on we understand that some part of business logic with complex calculation can be rewritten on Python by data science team. With microservice approach, we're able to do this. We can create independent service, implement this logic on Python, and make inter-process communication with our monolith and manage it by data science team. So as a result, microservice architecture gives us additional flexibility in technology choices. So the final example. Let's assume that you have large monolith application where components are tightly coupled between each other. So obviously it will make software development lifecycle slower and harder to manage. Implementation of new feature or bug fix can become a challenge, and meetings will be longer due to the number of people that must be involved in it, and etc. But in case you use microservice architecture and services are loosely coupled and can be deployed independently, then you can split large teams into streams and improve the quality of your software development lifecycle and reduce the duration of meetings and people that must be involved in them. Consequently, If you have a large application and obviously team that working on it, with microservice architecture, it would be easier to manage teams and software development lifecycle in general. Let's move on and consider pros and cons of microservice and monolith architecture. The first pros is monitoring, exactly because all logs and metrics are located in the same place. Faster and easy in the beginning, easier to maintain in the beginning. It means that we don't need to spend time for creation of pipeline and this CI/CD stuff. We'll have single pipeline for our monolith application, and the beginning it's easier to integrate with new changes. Common reusable components allows us to make changes in the single place, and it will be updated in whole application. So we don't need to create some libraries and do version control. Everything will be already inside of our monolith. As well, monolith use in process communication. It's a big benefit because inter-process communication quite slower. So in case you need to manage large amount of data or do thousands of method calls, better to use it inside of one service. Cons. Scaling is bad. So as we've seen, we can't scale some particular component, we can scale only whole monolith. Startup time. It can be painful in case our applications failed. We have to wait a long period of time to start our application back. Coupling between services, lack of robustness. Lack of robustness means that in case some of the component got critical issue, therefore whole application will go down. Hard to manage with large teams on latest changes. We captured it on the last example. Lack of flexibility, it as well was another example. So we're not able to use different languages inside of our monolith. It can be written only in one single language. And the second disadvantage of flexibility is as well that we can't scale some particular component horizontally or vertically. We can scale only whole monolith. Scalability. Scalability is ability to scale system easily, vertically or horizontally. It means that we can scale some particular service instead of whole application and be more efficient. Fault tolerance. In case some of the services failed, it doesn't mean that whole application will be failed. Independent deployment. Therefore, we made changes in specific service. In order to apply them, we need to restart only this particular service, not entire application. Faster startup time. As far as services are smaller, they run faster than in monolith. Easier to maintain by team. We can split our team to streams, and each stream will be care or will be responsible to some particular part of our application. Easier to isolate. As far as services are loosely coupled and we're trying to make it as loosely coupled as possible, we can easier to add new changes and make updates in these services. Flexibility. With microservices, we are getting a lot of flexibility. Most of them I've already captured. What I want to add that we're able to use any programming languages either. So some of the services can be written on Golang, some of them can be written on Java, some of them can be written on Python, for instance. So we can be more efficient in that way. Cons. Complexity. By complexity, I mean that it's harder to separate the service, harder to choose the right architectural approach or pattern. It's hard to make services loosely coupled. You need to think twice before you will make any step further, and etc. Slower in early stages. It's slower in early stages because of the complexity with additional CI/CD pipelines that comes to us. So for each service, we need to create separate pipelines and manage it. Inter-process communication, in comparison to in-process communication, extremely slower. So in case you need to make thousands of requests from one service to another or send some large volume of data, better to use in process communication. Observability. As far as each service deployed to independent process, we need to manage all metrics and logs from each of these processes, aggregate them, and join to a single one. Data consistency means that we are still able to use ACID transaction in microservice approach, but it's more common to have separate database per service. And in that case, we're facing with distributed transactions. There can help to us such patterns as two-phase commit and Saga, but anyway, we are losing this consistency and atomicity that we had with ACID transactions. Pricey on early stages. Microservices can be pricey on early stages due to additional complexity on the beginning to maintain of pipelines and time to integration between services and implementation and trying to make it loosely coupled, but it will give to us a lot of benefits in the long run. So let's sum up and understand when we need to use Monolith architecture. Arguably, if you're a startup and you're in early stages, it's worth to use Monolith architecture, and later on, when you will have larger code base, team, and customers, you can move to microservices by iteration approach. Iterative approach means to find out the root cause of the issue, some bottleneck for instance, then analyze benefits of porting component to separate service and implement it. So where to use microservices? Mainly in data-intensive applications, where availability and independent deployment is a key when you need to have ability to scale separate components and of course manage large teams and be flexible in technology choices. So that's it. In the end, I want to say thank you to Alex that helped me deeper to understand this topic, and to my girlfriend Julia that helped me with visual part of this video. I will leave their LinkedIn profiles in description box under this video with materials that I used for preparation. If you like this video, be sure to leave a comment below and don't forget to subscribe. Thank you. See you in the next one.